So welcome to today's video. So now let's talk about optical fiber. So here, soon after the discovery of lasers, some experiments were carried out on propagation of information through the light waves in an open atmosphere. A light beam acting as a carrier wave capable of carrying more information than the radio waves, microwaves. So, due to the atmospheric conditions like rain, fog, etc., so the efficient communication is disturbed. So, hence, to have an efficient communication system, the light which carries the information requires a guiding media known as the optical fiber. So, the fiber optics is the branches of physics which deals with the transmission and receptions of light waves using optical fibers which act as the guiding media. So optical fiber made up of transparent dielectrics, so that is SiO2, glass or plastics. And optical fiber consists of central core glass 50 micrometer diameter surrounded by the cladding which is 125 to 200 micrometers, so which is a slightly lower refractive index than the core. See the diagram. So the cladding enclosed by strength members and polyurethane jacket, so which act as a protective skin for core and cladding. So the protective layer is used so as to make the optical cable to withstand hot pulling, bending, sketching, rolling, etc. The layer also traps the escaping light from the core. And principle and propagation of light through the optical fibers. For optical fibers, the process of propagations of light is simple. So because once the light enters the fiber, the rays do not encounter any new surfaces, but repeatedly they hit the same surface. The reason for confining the light beam inside the fibers is the total internal reflection. So even for a bent fiber, the light guidance take place by a multiple total internal reflections all over the length of the fiber. The principle of optical fiber communication is total internal reflections. We know that total internal reflection takes place when it satisfies the following two conditions. So condition 1, the light should travel from denser medium to rarer medium. So where N1 greater than N2, so N1 is the refractive index of core, N2 is the refractive index of cladding. So condition 2, the angle of incidence on core should be greater than the critical angle, so that means pi greater than pi c. And propagation phenomena, so let the light ray transfers from denser medium to rarer medium. So N1 sin pi c equal to N2 sin 9 theta. So therefore pi c equal to sin inverse of N2 divided by N1. So the ray transfers along the interface so that the angle of refraction is 90 degree. Thus the angle pi c is called as the critical angle. So when pi greater than pi c, the ray is totally reflected back, so internally, so into the denser medium itself. So from the Snell's law, the maximum angle for total internal reflection pi c, so N1 sin theta equal to N2 sin r, isn't it? So already I told that conditions for total internal reflections, the light should pass from denser medium to rarer medium. The incident angle should be greater than the critical angle. And so we know the features of optical fiber. So it is light in weight, it is smaller in size and is flexible, so that it can bend to any position. It is a conductive, non-radioactive, non-inductive. It has a high bandwidth and low loss, so there is no short circuiting as in metal wires, so there is no internal noise or crosstalks. It can withstand to any range of temperature and moisture conditions. There is no need to ground, and hence no voltage problem occurs. Thank you. See you next video.